Everyone, in today's video we are going to try to fix this small DC to AC inverter. So what actually happened is that I tried to fool a grid tie inverter to power on without the grid while using this inverter, and what actually happened was that most probably the internal MOSFETs blown. So what I'm going to try to do right now is to replace these small MOSFETs. So how this thing was actually working so far was something like this. So on this end I had like this socket, and on the other side here I had like this small switch, and also some XT60 plugs, so I can simply put some drones, battery and things like that to power the whole thing on. So first things first, let's try to disassemble this thing and see what is actually inside. So as I've actually 3D printed this case, nothing special, so let's just pop this cover off. Of course I've actually looked at this before, so I know what's about it. So this is the board, of course, everything blown here and here, and of course I've bypassed this fuse since it used to blow quite easily, and repaired these trays that blown when I've actually added this inverter to the grid tie inverter. So next what we are going to do is try to actually take some measurements. Of course I've managed to forget my main multimeter, so I'm using this one, quite an old thing, but it is actually my very first multimeter, so I have to deal with that. So that's that. First things first, let's try to take some measurements. So what I'm going to check first is this small diode. It looks fine, so it should work. So the multimeter is working. So let's check for a short here, and here. So diode allows current to pass in this direction, and on the other direction, flipping the probes, it does not allow current to flow. So the diode is good. And of course the fuse is already breached here, so no problems here, only safety issues. And maybe these two transistors, they should be fine since they are on the low voltage side. So what I've actually managed to check before are these two MOSFETs or transistors here, this one and this one. So let's take some measurements. What I've actually noticed is that while doing this, there's really low resistance. Here, this one behaves differently, so there must be something wrong with these ones. So I've ordered in advance some replacements here. So let's take a look. If we have similar behavior, so between these two pins I shouldn't get like any visible readings, but maybe it's the behavior while this is still being soldered to the board. So I'll have to desolder these two MOSFETs or transistors and try to measure them afterwards. Behavior of this board looks something like this. Let me power on my bench power supply. Okay. And let's find the probes here. They should be right here. 1 second. Okay, so let's lower the voltage down to around 12 volts. Okay, this should be fine. And while trying to power this board, the LED gets on for a little while, and I'm drawing about temps at 1.8 volts, so yep, something definitely is fried. And after checking the heat, this one gets really hot while this one does not. So we know where all the amps are going, into this one. But I replaced both of them just to be on the safe side. So next we're going to remove these heat sinks. So let's start by doing that. I hope this screwdriver works. Quite hard, that one. So let's get this one first. Quite a long screw on these things. Okay, one is down. Let's try to get the other one. I'll try to not damage this coil, this transformer actually. So seems like I do not have that much luck with this one as the other one. The position is quite bad on trying to remove this thing, but I can twist it like this. I hope that I can then remove it from the board. So let's get this screw out. Okay, so there's that. So I know these ones are good. And next, let's try to remove these two transistors. So first things first, I'm going to try to apply some leaded solder to the pads here. And then let's see how it goes. I've already set this iron to really high temperature, and then I'm going to clear the tip, add leaded solder, and then we'll see how it goes. Okay, so let's try this solder sucker here and see if this one will work with us. Okay, not the results I was expecting. Maybe it will work. Maybe I should simply try to pull it from the other side while hitting all these pins. So let's give it a try. Maybe if I do something like, I don't know, maybe like this. But maybe with more solder on the pins. Or twisting from each side, maybe that will work. Maybe I should try to anchor it somehow to the table and then simply pull it up. I will come back in a few moments. Okay, so what we are going to do next is try to remove these MOSFETs from here. So I've already tried to desolder them with, and the trick that actually works is try to squeeze them so there is something pulling them down, and then simply hit them from above. So let's give it a try. Let's power on the soldering iron. Okay, so it is hitting right now. And then by simply hitting the pads, it should at some point simply fall down. Not the greatest solution, but this one should actually work. Okay, so I managed to pull one out. Let's give the other one the same treatment. and then we can start clearing the holes. So this one is already like this. Let me try to move this soldering iron somehow. Okay. I can already see it falling. And that should actually do it. Okay, so everything is down. Next we are going to try to clear the holes. So what I'll try to do is use this solder sucker to suck all that excess solder from the holes. So I'll try to put this clamp like this, so it stays in place, and then I'll simply hit from one side and use this pump from the other. So let's see how that goes. So next, let's try something like this. That seemed to do the job. Okay. Next, this one. That one worked as well. Okay. Not really sure about this one. That one cleared as well. Next. Clean. That one is clean as well. And the last one is already cleaned. So let's take a look. Okay, let's check if the new components will fit. So they should go in something like this. Okay. This one as well. Let's see. Okay, this one went through as well. Okay. So before soldering everything in place, let's actually give it a try to see if this actually works. So I removed this thing. Okay. These ones should be fine. They are already in place. They are making some contact. So let's see if this thing powers on right now. So minus and plus. Okay. It seems like something is not working properly. So this one gets really hot. So maybe it is faulty or something. Let's try another one. You know how these things are when you are ordering from China. So let's give this one a try. Okay. And let's see if we get better results right now. Seems we are getting the same behavior. So something is not fine. Maybe one of these guys is not having. Okay, so now it works fine. It draws about 0.08 amps at 12 volts, so about 1 watt of power. So everything seems to be fine. But before soldering these guys in place, let's try to maybe, just maybe, let's try to add the heat sinks first and then solder them back. So something like this. Okay. I have to get the screwdriver. And of course it is not here right now. Got it. So let's put this screw here. Okay. This way we don't have to deal with screwing everything back in place from a weird position. Adding the second screw, and then we can solder these guys back into place. Okay, everything is fine. I don't actually bother with adding some thermal compound or things like that. This should be fine. I don't plan on using this on any kind of high power projects or anything like that, so I'll simply add these guys in place and let's solder them back in. Okay, let's get some solder. Heating the soldering iron. Let's lower this. Okay, this should be fine. Let's wait for heat up. Not the greatest tip for the job, but it should get the job done. These THT components are godsend. Easy to solder. I don't like how this is soldering one bit, but what can you do? Okay. Actually, I could add some flux to these solder joints, so everything looks cleaner. Or I could just reflow them like this and hope the solder from the flux from the solder is enough for the job. Okay, this one looks really bad. I actually managed to make a bridge there, but it is not fixed. Okay. Everything looks fine. Okay. Let's clean the board and give it a shot one more time. Let's get some alcohol and something like this. Okay. Okay, everything looks good. Let's give it a shot one more time and then we'll see how it goes. Okay, looks good. I'll have to check out the output voltage and then there's that. I'm not actually brave enough to use this thing to measure that, but what can go wrong? Let's give it a shot. AC, okay. Let's set it to 1000 and let's hope for the best. Not really sure about the polarity of this. Actually, it's AC, so no polarity there. So what am I talking about? It will either blow or either work, so who knows? Anything can happen right now. Okay, this looks good. And let's hope nothing goes up in flames. Okay, and not really sure what about 1 100 volts maybe? Maybe it is fine, but as long as it works, let's try this. Okay, too much. Well, everything is fine. Maybe I'll give it another shot with some real appliances and see how that goes. Okay, so last thing, let's give it a shot. I've added its socket back in place. I've actually looked for some load, so what I've actually found is this switch. Nothing special, but let's give it a shot and see if it works. And okay, it seems it is powering just fine, so there's that.